was on Friday. No?
Wait, it's on Friday.
We've established that. We have not established that. Your final is on Friday. You do 1, 2, 4, 5, 3. This is 3. Friday is your final. Okay? So that means that seniors, I won't see you tomorrow. Juniors, I will. All right? There's not much we're covering tomorrow. We're just going to do like just practice. Okay? So you're not missing much in terms of what you do.
So we can do the course in a row.
Juniors, we do nothing. Next week, nothing. We're done. On the final.
I can't miss any.
Come in. Sit on the phone. We'll find a show to watch together. That's what we'll do. All right? You're not doing it. What's up?
Is that Friday like a regular day, or what is it?
It is a half day, but you'll go to all of your classes. It's such a dumb day.
Just like a regular Friday.
Yeah, it's a regular half day. You just go through your schedule.
Not for the seniors.
No, seniors are done.
So what's the schedule
When
tomorrow?
did it be done by then?
Tomorrow is the same schedule, but it's 4, 5. And your lunch is based on 2 tomorrow. But that's not it. You guys are 4, 5, 5. If you leave for graduation practice.
Only graduation.
I'm pretty sure. Alright, so Friday, which is your final exam, you have 3 open-ended questions, okay? This is one of them. You have to be able to do this. Okay? It's not like an open-ended final. You gotta know how to do this. This is our most recent unit. So that 5, does anybody remember what it does? It is the amplitude. I like that. Okay, so I can just go right here. Okay, what else? What else does it do?
It also multiply the y.
Y. What's it called? Why am I going Y's? Starts with a V. It's a vertical stretch. Vertical is Y values. So it's going to affect the Y values. You have to know the Y value pattern. If you don't, you could type like sine X into your calculator and see what values next to 0. It'll help you start it off. It's either 0, 1, 0, negative 1, 0, or 1, 0, negative 1. So it either starts with 0 or 1. If you type sine X in your calculator and go to your table, you can see it starts at 0. So it's 0, 1, 0, negative 1, 0. And the 5 is a vertical stretch. Vertical is Y value. So I'm going to multiply all of these by 5. All right, that takes care of the 5. Now we're going to the 1/4. Anybody remember what the 1/4 does? Go ahead.
It will stretch the x-axis.
Yes,
Like
it'll
X.
stretch the horizontal axis. 1/4 is a speed. 1/4 means that this person's running slower, right? 1/4 the speed of the original person. Making it slower stretches it out. This is called a horizontal stretch. So what it does is it takes the original x values, which are the corner points of the unit circle that we talked about yesterday. And what you're going to do is you're going to multiply by the reciprocal of the inside. So instead of multiplying by 1/4, you're multiplying by 4. Fellas in the back, you're not making great decisions. Just letting you know that. I'm trying to help you out, but you're not helping yourself out. Okay? So that's what the 1/4 does, and then what's the +3 do? It's the y, it goes up, right? So the y's, the outside numbers, stay the same. I'm not doing reciprocals on that. So I'm going to add 3. You can just go. So here's the math I'm doing to get this table. PEMDAS says I got to do the multiplication before I do the addition. All right? So 0 times 5 is 0. 0 plus 3 is 3. 1 times 5 is 5. 5 plus 3 is 8. 0 times 5 is 0. 0 plus 3 is 3. Negative 1 times 5 is negative 5. Negative 5 plus 3 is negative 2. And 0 times 5 is 0. And 0 plus 3 is 3. When you are multiplying fractions, you do not need a common denominator. So I could just put these over 1 and multiply straight across. So 0 times 4 is 0. Here I end up with 4 pi over 2, but that just reduces to 2 pi. Pi times 4 is 4 pi. 3 pi times 4 is 12 pi over 2 times 1, but that 6 pi, and 2 pi times 4 is 8 pi. I need you to be able to get the table. I need you to be able to get the amplitude, which Will told us is the number in front, which is 5. The period is the distance from start to finish. So from 0 to 8 pi, we've gone 8 pi. One of your 3 open-ended looks like that. Does anybody have questions on that one? You do not. Any other questions? All right, the second of the 3 open-ended looks like this. Take a few minutes, try one of these, okay? You will not have a unit circle template. You're gonna have to draw that up yourself, okay? We've done it enough times that I think you should be able to do that. Draw quadrant 1 of the circle and label in your 3 things, right? So you're not gonna have a template per se. You're just gonna draw it out. Or you can just focus in, solve it, and then try to remember that part of the unit circle. Okay, but it says, use a unit circle sketched by you to solve from 0 to 2 pi. So I would, when I do my sketch, really just focus in on this part of the unit circle. While I'm sketching something like that and filling some stuff in. Fill in your angles, fill in your coordinate points. I'm looking for 3 answers here, a reference angle and 2 standard angles. All right, so step 1, we're getting cosine alone, yes? How are we getting cosine alone? Divide by 2. Cosine theta equals negative root 3 over 2, okay? So the first answer I'm looking for is the reference angle. The reference angle is coming from where is x equal to root 3 over 2, because I'm never going to find x equals negative root 3 over 2. That doesn't exist on my unit circle. But where is x root 3 over 2? Keep in mind that the directions say 0 to 2 pi, which means I need the radian angle. Pi over 6. All right, so answer 1, pi over 6. We okay with that part? All right. Now I need 2 more answers. I need a quadrant something answer and then a different quadrant answer. I'm going to get those answers from all students take Calc. Cosine is negative. 2 and 3. All right. So cosine's positive in 1 and 4. So I need a quadrant 2 and a quadrant 3 answer. How you get that answer is up to you, whether you use a rule or a picture, right? So if I'm doing a quadrant 2 answer, here's my quadrant 2 triangle. And I know that this angle is pi over 6. I want this angle. Okay, so how you get that angle is up to you. The relationship is these 2 angles together make this half circle, which is 180 or pi. So my reference angle plus my standard angle equals pi. You can memorize that rule or you can see that in the picture. So I'm doing pi minus pi over 6. And in order to do that, I need common denominator. So I'm going to give 6's to the top and bottom. So 6 minus 1 is 5 pi over 6. So that's my answer 1, or answer 2. So I have my reference angle, answer 1, my quadrant 2 answer 2, and now I need a quadrant 3 answer. You don't need to draw the picture. I know that this is pi over 6. I need the 180 plus the pi over 6, or the pi plus the pi over 6. And so I need to find that common denominator. And so my third answer is 6 plus 1, or 7 pi over 6. Or you can switch it to degrees. Do the whole problem in degrees and then just change the answers back into degrees. There's blanks for it. It's reference angle blank, quadrant blank, answer quadrant blank. Like there's 3 blanks, so you'll know. Open-ended 2.
What's open-ended 3?
Open-ended 1. Open-ended 2. I don't have a template for open-ended 3 just because I do have to do some review there. Open-ended 3 is, here's a coordinate point. 5, 7. Plot it. Tell me the sine, the cosine, the tangent, the cosecant, the secant, tangent. So you'll have to draw a triangle and use Pythagorean theorem to find that side length, and then you can go through all sorts of things.
And you have this sheet with like the
You
sine,
have a formula sheet.
cosine, like you don't have to memorize any of that.
You do not.
Oh my god.
All there.
You're great.
Thanks, I tried. All right, I'm really hoping the scores are good. You'd be surprised at how not good they're gonna be. The same. It's depressing every year. I'm like, I just reviewed the crap out of that. I think the results are not good. But anyway, seniors, I apologize. Some of you sat through this already. So if you sat through this already, feel free to like just go to the white review guide and start doing review. All right. If you weren't here the junior prom day, this is what I did the junior prom day. Okay. So like if you were a junior or a senior that went to junior prom. All right. So I can find, and then these are the things. This is a midterm concept, so it's not an open-ended question. However, it was like a majority of the beginning of the unit. So it is about, I think it's like 8 to 10 of those 22 multiple choice come from this stuff, okay? And so I felt like it's a really important thing to review with everybody that's going to take the test. So these are the things that we needed defined in this unit, and there were like little strategies to do that. So page 3's got this little checklist. And in this process, you always want to factor first. And then from there, we can find all these other things. So the domain is the restrictions. And the restrictions come from when the denominator equals 0. Because if the denominator equals 0, then you have an error. And that's called a restriction. So the domain is coming from setting the denominator equal to 0. And so is the vertical asymptote. Both of those are the same thing. One is an x cannot be, and one is an x equals, but they're the same number. You can get the x-intercept 2 ways. You can look at the graph and find where the graph touches the x-axis. That's an x-intercept. Or you can set the numerator equal to 0. Ultimately, setting the numerator equal to 0 makes the whole fraction become 0, which is an x-intercept. A slant asymptote and a horizontal asymptote kind of go hand in hand. Actually, I'll go range next. So for the range, you want to look at a few things. You want to look at the mins and maxes. And the horizontal asymptotes. Those don't always impact the range, but they're the only things that do impact the range. So sometimes they will have no effect, and sometimes they will. It just depends on the graph. This is the hardest one. The range is the hardest of all of them. Y-intercept. There's two ways to do this. You can look at the graph. The y-intercept's where the graph hits the y-axis. So if you can read the graph, then just read the graph. The algebraic way to do that is to plug zeros in for all x's. You okay so far? All right, HA and SA go hand in hand. So I'm looking to do So you're going to basically take the first term in the top and divide it by the first term in the bottom, because usually the highest term is the first one. Sometimes that's going to get you to y equals some number, right? And that's your horizontal asymptote. Or sometimes it might be that, like, I have something over x. Like if it becomes like 1 over x or 5 over x, you might also have a y equals 0. Right, so there's two types of horizontal asymptotes. The y equals the 5 and the y equals the 0. The y equals the 6, y equals 0. Y equals -2, y equals 0. So like a number or 0. And you'll see that when you look at like the actual terms. A slant asymptote happens when you do that division and you end up with a linear equation. So you have to do synthetic division for a slant asymptote. This number out here is the opposite of the denominator. And these numbers in here are the coefficients of the numerator. A slant asymptote is a y equals equation, but it's linear. So it's like blank x plus blank. You only have one or the other. You don't have both. You either have a slant or a horizontal asymptote. Let's say if you have an absolute max, you call that bounded above. And if you have an absolute min, you call that bounded below. If you don't have an absolute anything, then you're not bounded. Right? You have to have a highest point or a lowest point to have boundedness. For the end behavior, if you have a horizontal asymptote of 2, then you have an end behavior of 2. If you have a horizontal asymptote of 0, then you have an end behavior of 0. If you have a slant asymptote, then your end behavior is the infinities, because now you're on a diagonal. So for the end behavior, you're checking your HAs and your SAs. And then finally, for your mins and maxes, if they're not obvious on your graph, you're going to have to do a second trace in the calculator. So instead of doing the review that's right below this, where we're doing all of the things for all of the problems, we're actually going to jump ahead and do a shorter review, just because we don't have a lot of time in this class period, and I want you to see problems like you're going to see on the final, all right? So we're going to go to, not these, we're going to go to final review guide 3 through 5. Let me see. That's not what I want to do either, actually. Let me pull up your. I want to do. I want to do this one. Did we do this yet? Page 5.
No.
All right, let's go this one as our practice. It's a little more focused. We're gonna do 2 through 7 here. Not 1, because that's not really the stuff we did today. But let's look at number 2. So on your final, you don't have to find all of the things for all of the questions. It's just going to ask you for like specific parts. So this one says find the domain and range of this. There are 2 ways to really do that. 1 by hand and 2 using the calculator. I recommend starting with the calculator, right? So what I would do is type that equation into the y equals screen. Don't forget to use that alpha y equals thing. So like, if I'm typing this into the calculator, if I alpha y equals it, I can get it in fraction form. So the numerator was 6x, right? And the denominator is x squared minus 9. And so at least from here, I can get an idea of what the graph looks like. The domain is the spot where the graph takes a break. So see how this is like 3 separate graphs? That means that the graph took a break in there, because if it was all one big graph, then the domain would be negative infinity to infinity. But because it takes a break, there's some sort of domain restriction. The domain restriction is happening right here at this break and right here at this break. So you can see it in the graph. It's at it's at -3 and +3. So if you can see it from the graph, then you don't have to solve for it. If the graph is stopping at -3 and +3. Now by hand, what you're doing to find the domain is you're finding the restrictions, which comes from setting the denominator equal to 0. So what I would do is I would factor that. And I would see that x can't be -3 or 3, because that's going to make the denominator 0, just like I could see it in the graph. The graph was stopping at -3 and +3. So in interval notation, it's negative infinity to the smaller of the two, which is -3, and then it takes a break, and -3 to 3, and then takes the break 3 to infinity. There's 3 different intervals because the graph had 3 different graphs on it. Each graph gets its own interval. Now, when I'm looking at range, the note said look at 2 things. Look at mins and maxes and look at horizontal asymptotes. So does this graph have a min or max? There's no U shape, right? But it does have a horizontal asymptote. It does look like it's leveling off. What's it look like it's leveling off at? It looks like it's leveling off at 0. So I would take that 0 into account. Now, 0 would be part of the range if that middle part of the graph didn't exist. We have the graphs that are like the outside curves, right? Because there's this graph that's going right through 0, now it makes the horizontal asymptote not matter as much. The graph can go through 0, right? Like in a domain, it's what can't x be? And a horizontal asymptote is what can't y be? Y can't be 0 out here, but it can be 0 in here. So that takes it away from the range. And so if y can be 0 and there's no mins and maxes, then the range becomes, any ideas? All real numbers. So the range for this one is actually just negative infinity to positive infinity. Good news for you is, even though range is the hardest one, these are multiple choice questions, right? So you knowing how to find the domain is going to eliminate probably half the answers. And then you're down to a 50-50 guess for the range. Does that make sense? Because these aren't open-ended. So one of your questions is going to be specifically geared toward domain and range. One of your questions is going to be specifically geared toward boundedness. So what you need to do is look at the graph and see if there's an absolute min or max. So I would have to type this into the calculator. Just make sure you're typing it like this. And then the bottom 5 and 6. Is that what it looks like? Is that the right equation? Yeah. Alright, so we're going to look at the graph. Do we see any absolute mins or maxes? I see an absolute lowest point of the graph, right? If there's an absolute lowest point of the graph, low goes bounded below. High goes bounded above, right? This is the lowest point, so I'm going to call it bounded below. If this graph was flipped, we'd call it bounded above. All right, so because there is an absolute min, this is bounded below. I think the options are like bounded above, bounded below, bounded above and below, not bounded. So you're just picking from. End behavior is associated with your horizontal asymptote or your slant, right? So really what I need to find here is the horizontal asymptote or the slant. So when I'm looking for horizontal asymptote and slant, I'm looking at this part. 4x squared over x squared. What happens to the x squareds? They cancel out. So the horizontal asymptote here is y equals 4, which means if we type this equation into our calculator, the long-term behavior is going to level off at 4. You can see it if you type it into your calculator. So 4x squared minus 12x and minus x minus 30. You can see like something's happening here. One way I taught you to find end behavior in the calculator is because it's end behavior, it's long term. You can go to the table and just put a really big number in for x. And you can say and see in the long term it levels off at 4 if you're not quite sure where it's leveling off. Another thing you can do is adjust your window so that you're seeing more of the graph. Like I'm not quite sure what that is, but if I extend it wider to maybe like negative 20 and 20, it becomes a little more obvious. Or you can just do it using the equation, right? Find the horizontal asymptote that matches the end behavior. Okay with that one? So we've got domain and range, we got boundedness, we've got end behavior. This is vertical and horizontal asymptotes. You can find these from the graph if you want, or by hand. So 2x plus 3 over x minus 5. Vertical asymptotes are the up and down lines, so something's happening over here. Horizontal is the side-by-side lines. Right, so you can see them in the graph. If you're good at reading a graph, you can get them from here. If you're not great at reading a graph, a vertical asymptote is the same thing as a restriction. What can't x be? X can't be 5. Because if the denominator is 5, then everything is an error. So that's the vertical spot that the graph's taking a break. The horizontal asymptote comes from this part. And what happens here is that the x's cancel out. And I get 2. Or go into the table in your calculator. If you're not quite sure where it's leveling off, go to something really big. You can see what it's leveling off at. Okay so far? I think there's 2 more. All right, find the slant. The slant is coming from synthetic division. And what we're going to do is we're going to put the opposite of this. So instead of minus 2, we'll put a positive 2 here. and then we'll put the coefficients of the top. The only thing is, a slant is a linear equation, and a linear equation has an m and a b, n x plus b. It only has two numbers. The third number is called the remainder, and I don't need it because it's gonna make my answer quadratic, and I want linear. The remainder is just like the extra stuff. We want the first two terms. So to synthetically divide here, we bring down the 1, multiply 2 times 1, and add. So my slant asymptote is x plus 7. So like they'll be just different equations. Look at this line. One of the equations is Calc y equals 5, which isn't even a slanted line. Cross that one off. You know, it's got to be linear. A slant is linear, so look at the linear ones. We can do a lot of elimination here. All right, last one. X and Y intercepts. You can do this directly from the graph if you want. So 9 and 8, let's say. X squared plus 9x plus 8 and x squared minus 3. If you understand what an x and y intercept is, you can read it right from the graph. An x-intercept is where the graph intersects the x-axis. The graph intersects the x-axis somewhere in here. Even if I can't quite tell, there's going to be options, right? Find the option that looks close. It looks like it's 1, 2, well, this one's 1. 1, 2, 3, 4, 5, 6, 7, 8-ish. And then you can look through the table. Second tray 0, you can do that too. You can read the calculated value. This looks like it's -1, right? And then a y-intercept is this one, so that looks like it's 2, -2. So you can read them directly from the graph, right? It's there for you. If you want to do it by hand, an x-intercept is setting the numerator equal to 0. So I need to set this equal to 0, which means I need to factor it. And then each factor is an intercept. So I couldn't quite tell if it was -7 or -8. It's -8. And the -1 I felt like was obvious in the graph. And then a y-intercept is just replacing all of the x's with 0. If you're doing it by hand. I could tell that it was -2 just from looking at the graph. So you can look at the graph, or you could do this. And ultimately this becomes 8 over -4, which is where that -2 is coming from. So I think I said there was like 8 questions. Looking at this, it looks like maybe there's 7. 6 or 7. I'm going to just say 6. Even with the hand. Is there 6? Did we just say 6?
How many questions?
Yeah, we just said 6. Maybe some of them are separate because there's 2 parts. Like maybe one of the questions is the VA and one's the HA. But this is like the general idea. You don't have to do the entire process for every question. It just like picks and chooses. Right? It's been a while since we've done that though. So I feel like that's a wrap. The only thing I did not go over with you was number 1 on that page. I don't know what page that was, but number 1 had like it's the only thing I didn't go over with seniors. Juniors, I'll go over one of those tomorrow. But you factor and you cancel. Division, keep, change, flip. Factor, cancel. Seniors won't be, but juniors will. So I'm going to review that with juniors tomorrow. It's literally 1 question on the final. It's the only one that seniors aren't going to see that juniors will. All right? That's it. Your final is Friday. Juniors, I will see you tomorrow. We're basically just going to practice tomorrow. There's not much left to review together. And then Friday's the day.